Right, year nine. So in today's session, we're going to be looking at something that's really difficult, and I don't mean the fact that it's hard to do. It's the fact you only do it once or twice for a few years, and then you're expected to do it in an exam. And students inherently find this really really tough. It is something and I'm going to give you an option. The option's really 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 simple. Some of you may have got as far, or you missed a lesson last week on naming compounds. I am more than happy with you guys continuing or start with naming compounds. But what I'm going to teach you today is balancing equations. And I'm going to teach you the ideas. I am going to teach you, how you are taught it in school. And then I'm going to teach you about how I think about it. So it all starts with equations. Now, there's a rule in equations, and before I forget, I'm going to tell you. These little numbers are the formulas of whatever you're using. These are the compounds. You cannot change these little numbers. Can't touch it, can't do anything. It's like saying I've got H2O. Do you know what? I'm going to put a 2 there. Well, you can't, because that's no longer water. It's something else called hydrogen peroxide, but it really doesn't matter. You cannot change little numbers. So I'm going to say that right now. All right. The other thing is there is a rule in physics. You cannot create or destroy energy, something I've talked about in physics. And mass, matter, substances is a form of energy. And I'll give you an example. The easiest way to look at this, and I've made these numbers up to make the maths easier. Now, I've got a carbon here and a carbon here. I can't suddenly have one disappear, right? You can do that in physics. That's called, nuclear physics, and we'll look at that later on. But in chemistry, you can't make the carbon disappear. You've got carbon. It's going to stay carbon. It's not going to change. But also the amount of stuff, the matter, cannot change. So if, for example, we've got a reaction where we've got 30 grams of methane, 70 grams of oxygen, while the total mass is 100 grams. So on the right-hand side, you can't have more or less than 100 grams. The mass doesn't disappear, and you can't create any. This is a really cool idea. So whatever I've got on this side, if I've got 100 grams total on this side, I must have 100 grams on total on this side. If that's the case, and if we've got 50 grams of carbon dioxide, we must have 50 grams of water. This is the idea. This is looking at mass, and we can ask questions like that. All right. So the idea, whatever you got on the left, you must have on the right. Okay. So then we come to this really interesting thing and this is what you looked at is balancing equations, but you used mass. Now we're going to balance equations, but we're going to use the symbols. All right, so I'm going to start off with this one. The method that is taught in a lot of schools is the train track method. You go to your arrow and you draw 2 train tracks. Okay, and this is how you got to do it. You've got to lay it out like this. We got big C, little a. This is not carbon, right? This is calcium. So just to remind you, the symbol of an element starts with a capital letter, right? So if we look at something like carbon monoxide, this is carbon, this is one element, because there's no little letter afterwards, there's no lowercase letter, that's the entire symbol. This is a capital, so this is a different element, this is carbon and oxygen. If I wrote as carbon and a little o, well, this is not carbon and oxygen, this is one symbol, and if you look on the periodic table, you'll find that's cobalt, okay? All right, but so let's start with this. Big C, little a, this is calcium. You're not supposed to know all these. I've done it for a million years, so I know it. Calcium, here's oxygen. So I put O. All right. So it's just the symbols, not the formulas, it's the symbols. Well, now I look on the left-hand side. So I look on the left-hand side. How many calciums have I got? Well, I've got 1. How many oxygens have I got? Well, I've got, that little 2 means I've got 2 oxygens, I've got 2 oxygens. All right, fine. Let's look on the right-hand side. Well, how many calciums have I got on the right-hand side? Well, just 1. Well, how many oxygens have I got? Just 1. My numbers aren't the same. Your numbers, remember what we said, whatever you have on the left-hand side, you must have on the right-hand side. Well, I've got 2 oxygens here and 1 oxygen there, so what am I going to do? Well, I need to double. times by 2. So put 2 there. Aha, no you can't. Because this is no longer, you've changed the formula of calcium oxide, you can't put 2 there. So what you do is you double everything. So you've got to put a big 2 here. All right. So now I'm happy, I've got 2 oxygens, I'm going to cross out my one, go, look, I've got 2 oxygens. But now I've got a problem, I've got 2 times 1, 2 calcium, so I'll cross that out and change that to 2. Now these aren't balanced. So I look at this, well, the only way to make that 2 is by timesing this by 2. Well, if I look on this equation, well, I just put a big 2 there. I cannot put a little 2 there, just remember that, you can't do that. So I put a big 2 there, 2Ca. And so now that is 2. So we've got a 2 there, I've got a 2 here, I've got a 2 there, and I've got a 2 here. I'm a happy man, it is balanced. Okay? Now, if you come across, oopsie daisy, equations like this, right? This is an organic molecule, it's a butane, I don't expect you to remember it, we've done organic chemistry. So let's have a look at what I would do here. So if I do it your way, train trap method, I've got carbon, hydrogen, and oxygen. Now, I'm going to put a big sticky note here. If you ever are looking at hydrocarbons, carbon, hydrogen, always start with carbon, right? Then hydrogen. Some people do it the other way around. I do it that way around because carbon's the easiest one to do. All right, so carbon. Well, let's do the numbers first. Carbons on the left-hand side, I've got 4. Hydrogens, I've got 8. Oxygens, I've got 2. All right, on the right-hand side, carbons, I've got 1. Hydrogens, now remember that 2 is for the symbol before it. 2 hydrogens. Now I've got to be careful with the oxygens. I've got 2 oxygens here. All right, let me just click that out. And 1 oxygen there. So it's 2 add 1. So I've got a total of 3 oxygens. Now, I don't care what my numbers say. I barely look at them. I start my carbons first. I've got 4 carbons here. I must times this by 4 because 4 times 1 is 4. And the only way to do it, let me change colours, is to put a big 4 there. All right, you cannot put a little 4 there. You must put a big 4 there. All right. Yeah, hey, I'm happy I've got 4 carbons. Do not look at the oxygens. We know we've changed the oxygens, but do not look at the oxygens. My carbons are happy. Now let's look at our hydrogens. 8. We've got 8 hydrogens. Over here we've got 2 hydrogens, but I want 8. So I'm going to times this by 4, because 4 times 2 is 8. All right, I'm going to put a big 4 there. Cross that out and change to 4. I'm happy. Way. Now that you've dealt, now look at my sticky note, deal with carbons and hydrogens first. I now deal with my oxygens. My oxygens have changed because I've changed the number of carbons and the number of hydrogens. So the first things first, I'll put a sticky note. Now check. So now at this point, now check your oxygens on the right-hand side or the products, right-hand side. Okay. All right, so let's check the oxygens on the right-hand side. So here now, let's change colour again. Let's make it a bit bigger. I've got 4 CO2s. I've got 4 times 2, 8 oxygens now. 4 times 1, 4 oxygens here. So I've got 12 oxygens in total. Now, if I look at my left-hand side, well, what would I do to 2 to change it to 12? Well, I'm going to times it by 6, because 6 times 2 is 12. So to 2 times by 6, I put a big 6 there. See, you're done. We're happy, because no longer have we got 2 oxygen left-hand side, we've got 12. So I'd cross that out and put 12, because now it's 12. All right, that's how you balance equations. It is mean, it is tough, but it's so much fun. All right, now let's stop recording.